Okay. Hello, welcome. I'm Dawn Attanasio. I'm the Assistant Dean for Energy Law here at GW Law School. Really pleased to be able to bring this program to you today. For anyone who is online or in the room, we are recording and we do intend to post this one. So if anyone has any concerns about that, please let me know or be aware before you speak. For those of you who are online, and at least one of you I know is in the building, there is free food available if you want to join us. So for those of you who are just joining us, and I see there's a few more people popping up online too, today we're going to be talking about sustainable fuels. Part of this comes out of my concern and interest that I have been interested in offering a program or a class actually in biofuels or sustainable fuels, alternatives to other liquid fuels. And there's a lot of misconceptions in this area and a lot of mystery, perhaps, about what is all that about. There's not the same kind of interest that we see, for example, from electrification of vehicles. So the purpose of today's conversation is to talk about what some of those myths are, to try to break through it and to produce some content that we'll be able to put online. And my co-host, Joanne Ivancek. Is the Executive Director for Advanced Biofuels USA, and she will also post it on her website. And so there will be a possibility for a very wide audience eventually for this program. So with that, Joanne, okay, I'm going to turn it over to you.
Thank you. I have some slides. Can you put the slides up?
Yeah.
Yes, I am Joanne Ivancek. I'm Executive Director of Advanced Biofuels USA. And so welcome to all of you here in the room and online to this collaborative discussion about communicating about renewable fuels. As we noted in the roundtable discussion, the goals are to bring thoughtful voices into an important conversation and to disseminate the ideas and information gathered. So I encourage you all to candidly engage in this conversation here and in person and online. And those of you who are online can raise your hands, and Donna will be monitoring that or put questions into questions into the chat box, and we will get to those. To start, I want to tell you a little bit about our Advanced Biofuels USA and about our resources, and then take about 5 minutes to address the first item on the agenda that is with a few slides as a foundation for the conversation. So Advanced Biofuels USA is a nonprofit educational organization. Our main tool for achieving these goals is our website at advancedbiofuelsusa.org. Here is what it looks like. And to use it, I suggest using tags and categories. And if you want to get the 30-minute recorded version of what we're going to go through in 5 minutes today, it's in the education section, which is circled there on the slide. So to go quickly over what are sustainable renewable fuels, and then we'll talk about how are they used and how are they made. A lot of people will know ethanol. Ethanol is a biofuel, not the only biofuel. Here are renewable diesel, sustainable aviation fuel, which is known as SAF, and all of these other things and more. So don't think of just ethanol or just corn ethanol as a renewable fuel. But when you do think about that, when you hear about first generation biofuel, that's usually talking about corn-based ethanol, sugarcane ethanol, soy-based biodiesel or renewable diesel. The other thing that people don't always understand is ethanol is that same molecule that we find in beer and wine and spirits. So that's what it is. That's what they are. That's what we're talking about. So how do we use them? We do use renewable fuels now, fueling cars, trucks, equipment. One of the main reasons that we use ethanol is it replaces MTBE, which is a serious carcinogen and was being banned in many states. It provides octane. It's also Renewable fuels are also ultra low sulfur fuels. They can also be used in fuel cells. And we're using them to fuel aircraft. Not much at the moment, but growing every day. Fueling trucks. This is also something that has been growing lately, is fueling trucks with renewable natural gas, biodiesel, and renewable diesel. And like I said, fueling aircraft. Also, which is getting more attention, is fueling locomotives, trains, and buses, often with some renewable natural gas. And the chart here, this will all be available on our website, is shows what your comparison of your carbon reduction is when you do use renewable natural gas. We're also using them in marine and maritime fuels, and we'll talk a little bit more about that later too, particularly because the International Maritime Organization has new regulations out that require low sulfur fuels, and there's more and more companies looking at renewable fuels to meet that requirement. We're also using them for military applications. And again, racing is becoming a test bed again for new fuels. They had been for a while. IndyCar has used E85 for a long time. And now there's a lot more attention to going to looking for 100% renewable fuels for racing. To see the impact that our current use of renewable fuels has, you can look at some statistics from California that actually keeps better track of this because of their low carbon fuel standard. And you see that the renewable diesel, biodiesel, ethanol, biomethane are the key ways that we have been able to reduce the carbon footprint in transportation. And other uses of renewable fuels that people don't always think about is heating oil. And that branded as bioheat has become a really big thing, particularly in the Northeast. And around the world, to do a very important thing of reducing the soot, the harmful smoke that comes from using dung and wood for cooking, moving to ethanol and maybe methanol made from renewable sources. Again, now tomorrow, what are we going to see tomorrow? Hopefully we will be seeing optimized flex fuel vehicles. Hopefully we'll be just seeing more flex fuel vehicles that can use higher blends of renewable fuels. There's renewed interest in plug-in hybrid flex fuel vehicles that can use ethanol, high ethanol blends, and drop-in petroleum fuel replacements, the rest of the gallon, so that you're not just doing E85 and only having the E part be renewable, but have that other 15% also be renewable. And looking at 100% sustainable aviation fuel. Like I said, using renewable fuels for the fuel cells. So hydrogen or ethanol can be renewable. They don't have to be, your fuel cells can also, fuel cell cars can also be renewable fuels. And think of missiles and rockets. So a quick review of how are they made. How are they made has basically three parts: feedstocks, logistics, and technology. And when we think of feedstocks, what do we make these fuels out of? We're going to think agriculture, we're going to think forestry, we're going to think that circular economy of waste management. On the 30-minute version of this, you can see pretty pictures of all of these different kinds of potential feedstocks and more. But just to understand, we're not just talking about corn ethanol. We're not just talking about what some people are concerned about food, things that can be used for food also being used for fuel. There's lots of other options. Logistics. These are new feedstocks often, things that haven't, we're talking about things that haven't been done before. So we need to build the equipment to harvest it, to store it, to transport it, to move it around, move around your fuels and to move around your feedstock. And the other sort of logistics and infrastructure that's being looked at is carbon storage. So taking the ethanol, the carbon dioxide made out of fermentation and being able to store it. And other technologies on how do you convert from these feedstocks to your final fuels or your pathways to the final fuels. And here's just some of the processes that are used to do that. And the concept being that we're going to leave, as much as possible, leave fossil carbon in deep storage and recycle the carbon that is already above the ground. One of the most ubiquitous ways of doing that is photosynthesis, where plants collect that carbon that's in the air and convert it to substances that then we can turn into not just fuels, but everything else that we really make out of petroleum and natural gas. So this is what we have. These couple slides are done by a student from Hood College who was volunteering with us. And he wanted to picture what we were talking about. This is what we have, and this is what we could have. That's it for my slides. And what I would like to do is then move into who are we that are part of this conversation, and then get into it a little bit more. So you know who I am, and let's.
Some of the people who joined on the line do not.
Okay, then I'm Joanne Ivancic, Advanced Biofuels USA Executive Director, and I am facilitating this conversation. So I want to go around the table here, and then we'll go on to online.
Mm-hmm. Push the button because they can let you be online.
Michael McClay, systems engineering is kind of what I've been doing for the last, for a long time. I worked at NIST on energy standards for, substations. How do you protect those against cyber attacks? So that was one of my last projects that I worked on related to this, and be very afraid. The grid, as you know, can be taken down with with a high power rifle. It's not really the safest way to move energy around the country. It's subject to a lot of things going wrong. I'm interested in building habitats that float in the ocean that can house, think of it as refugee platforms, or when a community gets displaced by some terrible storm, you put them onto essentially a cruise ship, but supersized cruise ship. They'd be powered using molten salt reactor technologies, very safe form of nuclear power.
So I'm Nancy Young. Nice to see everybody. I am an aviation, environmental, and sustainability attorney, largely environmental attorney for many years, since 1990. And I have been in the sustainable aviation fuel space since 2006, when the airlines collaborated with the Federal Aviation Administration, the airports, and the manufacturers to come up with a way to have sustainable aviation fuel in aircraft in a commercial way that would be completely fungible with regular Jet A fuel. Over the past year, I was the Chief Sustainability Officer at a startup biocrude and sustainable aviation fuel company. And now I'm a sort of freelance lawyer and consultant working in this space. Thank you.
Heather, thank you for today's presentation. My name is Gregory Holliday. I'm a consultant. I work with international development nonprofits, and I'm doing a lot of work and learning more about environment, sustainable environment. So really, I'm just here to sort of listen and learn from you all.
Go ahead and introduce yourself since you're the master of ceremony here. Anyways.
Okay, I'm Yingzi Dai, and I'm the program associate for our academic programs, and I'm helping Donna with her energy law program and putting on this event. Hi, I'm Erica Hackett. I'm a 3L here at GW, and I'm just here at this event to listen and learn.
Hello, everyone. My name is Sean Davis. I am a senior policy analyst at ITIF Information Technology and Innovation Foundation. I work in the intersection of essentially digitization and lowering carbon emissions. So looking at different technologies that can be impactful in reducing carbon emissions and reducing energy use. So just here to learn.
Found the button. Hi, I'm Bob Kozak, president of Atlantic Biomass LLC. We develop enzyme systems and processing systems to take low-cost biomass into biofuels. And for being at GW, I might as well tell you a little bit about my connection with GW. I was the first graduate of the university's environmental science program, and you can look it up in the far deep archives and you'll see what year that was. And our enzyme research actually just started down the street in Bell Hall in the laboratory on the third floor. So this is like coming home.
I'm Donna Antanasio. I'm the Assistant Dean for Energy Law. I want to thank you all for being here. For those of you in the room, there is lunch in the adjacent room. You go through that door and turn right, or the other door and turn left. And please help yourselves and bring it back in. Feel free to munch as we go along. Again, thank you all for coming. I appreciate the folks on the line. And now let's turn to those folks. And let's see, I have somebody who signed in as AAPEFB. Do you want to introduce yourself?
Sorry, Donna, it's Dave Woodworth. I'm using my airline iPad for the screen. So sorry about that. Joining everybody from Phoenix today. As I said, I'm David Woodworth. I'm an adjunct professor at GW Law, where I co-teach a course on aviation and national security law. Was fortunate enough to have Erica as a student last fall, and do appreciate Donna and Joanne for putting this together, and always happy to see some old faces in the crowd. So thanks. Joining you from Phoenix this morning.
Thank you, David. Jenna?
Hello, my name is Jenna Bloxham, and I am a board member of Advanced Biofuels USA. And I'm also a PhD candidate at Colorado State University. When I started my PhD, I was part of the National Science Foundation's iGroup program related to bioenergy and biofuels. And after I completed that program, then I taught other PhD students regarding biofuels and bioenergy policy. And I'm happy to be here today.
Thank you. We're delighted to have you. Farron?
Hi, my name is Farron Bartholomew. I'm Dean Antanasio's research assistant, and I'm a current 2L at GW, and I'm excited to be here today.
Very happy to have you. Kate?
Hi, everyone. My name is Kate Morgan. I work at Delta Airlines as a senior analyst in the Government Affairs and Sustainability Office, so working closely with sustainable aviation fuel efforts. I also will be graduating in May from GW with my master's in environmental resource policy.
Fabulous. I love when we have crossovers among our schools. That's always really helpful. Jay?
Hi, afternoon. My name is Jay Rick. I'm excited to be here. Just, excited to learn and just figure out how to use my kind of rocket science background to try to get into policy and help kind of with the efforts with, I think, the nation's energy issues. Most of my career has been in space exploration and aviation down below the atmosphere. And so just trying to figure out creative ways to get HBCUs and of course, develop the next
Take your stick.
generation.
I'm gonna turn my soup off. All right.
Robin, I think you're, Jay, go ahead and finish.
Oh, yeah, here to learn and figure out how to be useful.
Well, we're delighted to have you, and it's interesting both in the programs that we've had about nuclear fuel as well as biofuels, that the issue of space exploration comes up. So clearly there's a lot of ground for us to cover and the space here to cover as well. Robin?
Apologies about that. I think I was anticipating it being my turn. I'm just an interested staff member for GW, trying to find different ways to preach and live sustainably. I work with study abroad students, and of course, we're kind of grappling in our field with all the travel that we're promoting travel and air travel to our students. And I think we're trying to reckon with how to kind of keep going in our field, but also not destroy the planet. So I'm interested just to kind of hear from people about what is happening, what advancements are being made.
So delighted to hear that. I really appreciate when we have staff members and administrative people that get involved in these conversations too, because obviously we need to learn to walk the walk as well as teach it. So thank you. And Joanne, back to you.
Okay, so to get started, what I wanted to talk about, get us to talk about is key points and misconceptions about sustainable fuels that need to be communicated better and how we might do that. So do any of you want to come up with and tell us what is a misconception that particularly concerns you and what do you think we can do about it? Okay, Nancy.
Well, I think the question of what is a sustainable aviation fuel or a sustainable fuel in general is not understood. And in part, and Joanne, you showed a really good chart before on the recycled carbon kind of cycle, and think about how complicated that is. So if talking about communication, what we're really talking about is improving the life cycle greenhouse gas emissions benefit through using these fuels. To understand that and what that really means is difficult. And I was just listening to a Senate hearing yesterday where one of the senators said, you're not doing anything when you use a biofuel because you're still emitting carbon. And clearly he did not understand the life cycle greenhouse gas emissions that throughout the process, as you explained, of growing a plant, agricultural waste, agricultural product, municipal solid waste, you've captured carbon in that process. Yes, you're turning it into fuel and it gets re-released, but you're displacing the emissions that would have come from petroleum that had been in the ground for millions of years. And that's the point. You're recycling it rather than adding more carbon. So a misconception is sort of understanding that even if your biofuel does release carbon, you look at the life cycle, there is that benefit.
So what we can work on is getting more of that conversation about recycling carbon, leaving stuff in deep storage, and getting people to understand or remember their fifth grade science class when they learned about photosynthesis. And I think that more, as I'm going to conferences and things, I think I'm hearing more of that emphasis, that discussion, that not assuming that people understand photosynthesis, that people don't understand that a plant takes carbon from the air. And so maybe what we can all work on is repeating that when we have the chance. Any other? Yeah, Kozak.
Nancy said something really, she used a word you don't hear enough of, which is replacement. And I think we've lost track of that. Like, so when that senator goes, we're really talking about is replacing petroleum-based fuel. And I think that's, I haven't heard that enough. And I think that's something we all ought to put in our brains, that replacement is the key word.
Anybody else? Anybody else here? What about online? Please
anyone
put
on
things in the chat box or raise your hand.
Yeah, raise your hand and we can call on you. I would just like to add, I mean, I think the other misconception is, first of all, as you pointed out, people have heard about ethanol, and that's kind of like almost the limit of their knowledge, and not understanding the full range of uses. Again, ethanol, oh yeah, we can blend that with gasoline and put it in cars, and not really understanding that there's an entire additional things, including, for example, the use of fuel cells or other ways in which we can apply this technology, that it could be very productive for carbon fights.
And if I could also add, sorry.
They're finicky.
Okay, if I could also add, a lot of us think about ethanol just being from corn, but now there is carbon capture that can make ethanol, and LanzaJet and LanzaTech are really innovating in that area, and there are a number of other companies that are doing that as well. Where there are folks that are doing ethanol from woody waste and other things. So it's to your point, Donna, there isn't just ethanol. In fact, we can talk about the lots of different types of fuel, but you don't just make ethanol from corn. And that actually itself is its own innovation. When you talk about the question of food versus feed, is there a question? That's a question. Is there a question? But there could be other feedstocks to make even that fuel.
Just to even build a little bit further on that, I mean, I think that the other thing that surprised me was learning more about the processes and how interconnected so many of these processes are. I mean, making hydrogen isn't that different in a sort of chemical manufacturing sense than other types of fuels. I mean, it's kind of a little bit of a continuum. They're all chemical processes. It's a question of, what are your inputs? What is your process? What is your output? What is your intended use? And I don't think I really kind of understood how cohesive, in some sense, this field of alternative fuels is. Yes.
If what we're talking about now is the sort of the misconceptions of people who maybe don't understand as well, then you're lucky to have me here, because I've never been part of these conversations before, so I'm the perfect foil for it. So what you were saying about corn-based ethanol, my concept of it is, yes, that I thought it was all corn, or at least mostly corn, and then a concern of somebody like me who knows very little, but has a concept that the U.S. government subsidizes corn production in the United States. It's a monoculture. It degrades the quality of the soil, and that corn is used for ethanol, but it's also used for other things like high fructose corn syrup, which is going into our processed products, which is not something that we love. So how do you address those kinds of issues? Thank you.
At Showcase of Growth Energy, we're the world's largest corn ethanol trade association. You have a few thoughts.
I love these conversations.
I think part of the answer lies in understanding the complexity even of the corn commodity itself. So, for example, corn that's used to make ethanol is not the corn that's used to make corn syrup or sweet corn, which is what humans consume. And to this point about the diversity of the production process, corn is used to produce starch ethanol, also has a whole set of other products associated with it, in particular feed. So corn that would otherwise be used directly as feed is being created as a co-product of ethanol production. So it displaces some further corn acreage that would otherwise be used as feed. So there's some efficiencies to be gained by using ethanol, so it's sort of feed corn for both starch ethanol and for high protein, higher density feed. And I won't speak necessarily to the corn subsidy issue or the agricultural market, but there is definitely some value to be brought in the feed space by having sort of ethanol production continue. As far as acreage, our position has always been that increased technological innovations in corn production will continue. There is less corn acreage now than there was in 1950. 5 times the amount of corn. The amount of fertilizer being used decreases annually. So, every activity is going to have an environmental impact, ecological impact. That's just sort of undeniable. But I think this particular commodity improvements being made every day are sort of something that's undervalued and underappreciated.
Joe, could you introduce yourself? You missed the round
Oh,
of
I'm sorry.
introductions.
Yeah, I'm Joe Kakish. I'm general counsel at Growth Energy. We represent ethanol producers and affiliated companies in the United States.
Thank you. Michael, before this, you were talking a little bit about an ammonia production process in, I think, Norway.
Yeah.
So can you just describe that briefly?
We do have a couple of comments in the chat, Chip.
Yeah.
You want to do the chat?
And well, no, just briefly.
Well, one thing I want to mention, I grew up in the Midwest, and all my friends were living on farms, basically, and they grew corn. And the way they grew that corn was to inject anhydrous ammonia into the soil as a fertilizer. So what we're really actually doing right now is eating natural gas indirectly, because we take natural gas, strip off the hydrogens, combine it with nitrogen using the Haber-Bosch process, and then you have ammonia. The part about using the natural gas is what we have to get rid of, and instead you can do electrolysis. And in Norway, they were making anhydrous ammonia many years ago, but they were using the hydropower that they had. That was just excess hydropower. They had lots of cheap electricity that they could use to just split off the hydrogen and turn it into ammonia. But the future, I think, is going to be towards using nuclear power to generate the heat, and then use high temperature electrolysis and high temperature formation. There's several different processes that are available for doing that, but that's going to be probably the cheapest way to produce ammonia for use as a fuel. Once that's gets down below the cost of the other fuels options, people will have an incentive to switch over to using that as your basically. And right now, I just forwarded to YouTube the celebrity, I think it was Celebrity, one of the cruise companies just launched a ship that is using anhydrous ammonia as their fuel. And this gets rid of all carbon emissions, because when you burn it, it goes from being anhydrous ammonia to being water vapor and nitrogen, and the atmosphere is like 70% nitrogen. So that's like not a problem.
Thank you. And now let's go to the.
Sure.
I also thank you for connecting us to the maritime uses for fuels.
So Jenna offered a few other misconceptions, the ones that she hears very commonly, 3 of them. One is that biofuels don't have real environmental benefits. Another is that biofuels aren't feasible at a meaningful scale. And the third is that biofuels are just a stepping stone technology that will be outdated soon. Anybody want to comment on any of those? Jenna, do you want to comment on some of those?
Sure, I certainly can do so. Yeah, I've taught people who are PhD students across a lot of different fields, mostly engineering and science, and I've taught students who have no idea what biofuels are. But these are kind of the main 3 ones that they think that biofuels have maybe a negligible impact, but they're presented more as a kind of a PR kind of feel good story so that people stop worrying so much. And of course, the oil industry has contributed a lot to the doubts that biofuels, regardless of what type they are, can really make a big environmental impact. I think that people are also, one of the things that the industry has failed to do has really talked about what huge impacts it's had and what huge scale that ethanol and biodiesel have actually operated on, both in the United States and around the world. And that I think the biggest thing I see now, especially with the new technologies coming out, sustainable aviation fuel and renewable diesel, is that these are just, these are just kind of stepping stone technologies, or these are just kind of placeholders to get to the real good stuff, like EVs and hydrogen and electric planes and all of these things that are so far, I think, in the future that but people think they're much closer. And so I think there's not a recognition, which of course drives me crazy. There's not a recognition that biofuels are really are cutting edge of the future, especially some of the new aspects we have with replacing true hydrocarbons as opposed to kind of just alternatives.
Thank you. How about let's move on to is there anybody else? Okay, go on,
Things
Nancy.
you want to say about Jenna's comments?
Yeah, I just wanted to add a little bit on the scalability issue and the misunderstandings about, oh, you'll only have it for a little while because you'll get these Star Trek technologies online. Really credible analysis shows, and I'm going to speak about the aviation industry, but there are other industries that are fuel efficient or very hard to decarbonize otherwise, and they will have liquid fuels for generations, for decades. Aviation is one of those where aviation is working on hydrogen aircraft, working on electric aircraft, working on hybrid electric and other things, but all of the analysis shows that you'll only see those in very small George Jetson sized planes or maybe a little bit bigger for the next 20, 30 years. So all of the airlines, the US airlines did it in 2021 collectively. Some of them before that have declared the goal for net zero by 2050. The world's airlines have now done that. And to get there, all the analysis shows that about 60% of the contribution at least is going to need to be sustainable aviation fuel, which is a liquid fuel, even injecting those other technologies over time. And a large part is because those other technologies aren't ready in a safe way and won't be ready in a safe way to move lots of people in the air for distances that matter. So there's a real drive, and coming back to Bob's point before about replacement, to replace petroleum fuel with sustainable aviation fuel. And it's actually a way to kind of transition the liquid fuel market over time as well. Instead of leaving stranded assets for refiners and others, you can refine the fuel into renewable diesel or renewable jet fuel. And that's a good way to really leverage your existing assets.
That might nice segue into our next topic of what skills and knowledge can help the workforce, corporations, and investors successfully navigate the world of sustainable fuels. And one of these ways is that if we have oil refineries that aren't going to be making petroleum products anymore, they and all of that workforce that has those skills can transition into just different feedstocks, making renewable fuels. I got a couple other things, and then I know that Bob Kozak has some slides that he has, but let Donna see who else is on.
Yeah, I don't see other hands, but I want to respond to Nancy, but I think it ties into that too, which is, so right now I'm thinking about the ground fuel uses of biofuels. And right now we have a big effort to build out the electric system, and people sort of think, oh, electricity, it's everywhere, but it isn't really. If we're talking about trying to electrify highways and, make it available, we have to really build out the electric system to be able to carry that high voltage to the places where it's needed. So if we're talking about using biofuels for ground transportation, we're then, I guess it's both a question and a comment, how much of the existing pipeline system, trucking system, distribution system can we use for biofuels without replicating and creating yet a third system for distributing fuel? And will that then, because often when you make a big investment, that itself means it's going to last for a long time because you made the investment and people don't want to shut it down. So does that mean that we will then in parallel have biofuels for ground transportation along with electrification? So each thing can kind of find its own niche. Maybe it's passenger cars are going to be more electrified and trucking might be more biofuels. Is that a feasible future or,
May I say
Please.
something about that? and Joe will probably jump in on this with it. When we switched to 10% ethanol back in the early part of this century, we did it really fast. And part of the reason we were able to do it really fast was that we used the existing infrastructure. I mean, ethanol that comes to the East Coast either comes by rail or by barge. People don't even know how much comes by barge. Biofuel ultimately is a liquid fuel. Anyway, ultimately you ship the liquid fuel, you can ship biofuels. And the point of this is electricity needs a huge investment in a new infrastructure to move the electricity around. Biofuel doesn't. So again, we're talking about replacement. We use X number of barrels of liquid fuel a day. It could be by petroleum or by biomass sources. It's essentially the same infrastructure. So if you look at it, we're a low-cost solution. We don't need an infrastructure. It's there. We can go with it. We're doing it already. We can gear it up. And I think this goes back to everybody saying that we have to stop CO2 pollution. And electricity for cars, is 30, 40 years out. If you look at the price of the cars and fleet turnover, it's not happening next week. If you really want CO2 reduction immediately from the transportation sector, you switch fuels.
If I could just quickly, I'll just pick up on that really quickly because I completely agree with Bob, and to give it a punctuation for in the sustainable aviation fuel space, when sets of us were deciding how could this actually be done in a real commercial way, we knew we had to drive those who would make a bio-based jet fuel to the jet fuel specifications so that it would be fungible with the existing aircraft, the existing pipelines, the existing distribution system. There's, as I think Joanne mentioned at the very beginning, there's a very tiny amount of sustainable aviation fuel now, but that gives us the opportunity, like one of the folks on the line from Delta Airlines, they recently did a pilot showing you can put it in the pipeline just fine and bring it to an airport. And we knew that already, but of course you have to do that. Very good point. And I think that's a good way, Donna, to your point, to have kind of a mutual transition as you move the grid along, which will be slow, and all the infrastructure for that. You can move these biofuels along, and you're going to need all of the above.
Thanks. If I could just add to that, and also just to respond to something Jenna raised in her questions, is this framing of the energy transition. Sometimes when you treat liquid fuels as a transitional fuel to something better, there's a sense in which the liquid fuels become devalued, right? Which to our mind leads to leaving carbon reductions on the table that could have readily be incorporated today. And that's one of the sort of strongest messages that you can develop to counteract this devaluation is, if we're thinking about biofuels today, carbon reductions that can occur today, which is just as valuable as the carbon reductions that are happening 20 years down the road, there's no reason to limit the impact of biofuels given our current infrastructure and current technology. So I find that there's this kind of privileging in some ways of the shiny object off into the future at the detriment of existing liquid fuels and biofuels capabilities.
Just add on to that, you said is valuable in the future as today. The things we do today are more valuable because when we think about the problem of carbon compounding, the earlier we make these reductions, the more important it is. So in that respect, having early solutions does actually have a value, and to the extent we can ramp up production and do more now, that actually is more valuable.
Any more comments on this part of it? Okay, then let me go into this next part about the workforce and corporations and particularly since we're in a law school. When Bob Kozak heard about this discussion, he wanted to talk from the perspective of an entrepreneur and a startup business owner about what skills and knowledge he needs. He's particularly interested in protecting proprietary information. And so he's got a couple of slides. Can you bring the slides up for Bob that include language on that point to demonstrate what lawyers might encounter what, as they're working with people in this industry, especially startup and entrepreneurs, because as I said before, a lot of this has not been done before. And so there's a lot of new intellectual property that is being developed. And so that's just one piece of the workforce, one piece of the legal workforce that he'll talk about. No.
What?
No, you can use this.
Oh, that's it. That's it. Modern technologies here, slowing things down. Thanks for giving me a couple of minutes here. I want to talk about where, to law students primarily, and the law students get from leave, what I call the future of IP, biofuels, and lawyers, the 2023 perspective. Okay, works from here. We were talking about different biomass sources. And one of the things of so-called advanced biofuels are that it's not corn. And sort of the requirements of advanced biomasses are, one, they're cheap, they have high yields, and they convert easily. Well, lo and behold, we've discovered something that works really well. It's hemp, or as it's called in certain states, cannabis. And we aren't interested in the top part, the pharmaceutical stuff, but you see all those, if you see there on the left, you see all those branches and leaves. Those plants were planted in February, and their yield is about 10 tons per acre. And if you translate that out, that's going to be somewhere around 700 gallons per acre. Currently, cornstarch produces about 450, 460 gallons per acre. So there's a lot of interesting stuff there. So, we're working on something called hemp crude, converting the residual hemp leaves, stems, and stalks to SAF biofuels and bioproducts. And that's how the way we do that. So just want to give a little economics on biofuels. And the first thing to remember is biofuels are a commodity. And by definition, they're low profit. We would like to have it that way, but all the way from oil, all the way through, they're a commodity, they're low profit. So how does a company in the space increase their revenue? Well, how are profits maximized? First of all, is vertical integration. John D. Rockefeller perfected this. I'm a fan of John D. Rockefeller, but he got this thing right. If you control from growing to final product, you've taken out the transfer, rental, and licensing costs. There's more profit potential there. The other one is to own and license key technologies. And from our point of view, from a biomass thing, it's if you own the enzymes, the conversion processes, you can license them and get income from that. But this is where, for the law students, is the key technologies must have modern IP protection. And I'm saying modern IP protection because I postulate, and I don't postulate it, it is, we're in the post-patent era. We all grew up when, if you have a new technology, patent it. It's the way to go. And the idea was that patent laws are enforced. So you can do it. You don't really care if people have seen how your process works, as long as the patent protection system works. Well, nowadays, intellectual property theft is a huge problem on the international stage. China flat out doesn't respect any intellectual property from here. India is not all that great either. So it's a real problem. So what we have to do now is to find other ways to protect our IP. And this is kind of interesting. We just signed an agreement with the state of Maryland, their Energy Innovation Institute, for funding of this process. And they offered us something new. It says an option for commercialization license when patent protection is not being sought. Now, 2 years ago, when we talked with the state of Maryland about this, they said we had to get patent protection. But now they understand that patent protection maybe doesn't give you the best way to protect your IP. And it says right there, we can license unpatented inventions under this program where we couldn't previously. So this goes back to, well, if we're looking for lawyers to handle our IP, what are we looking for in the future? First off, we need somebody with strong grounding and originality and non-patent IP protection. It's just the way it is right now. Secondly, knowledge and experience in crafting agreements in countries without treaties with the United States. Now, this is something that I wasn't quite aware of, but if you think about it, we don't have any commercial treaties with most of Latin America. We don't even have commercial treaties with Brazil. So when we are entering in, for instance, we are working with Ecuador at this moment, we are not operating within a treaty framework. So we need people who can help us on crafting agreements in countries where there aren't commercial treaties to fall back on. And then finally, the ability to craft vertical integration business arrangements, because that's ultimately where we're going to be going into. So I just wanted to give a little bit of our perspective of what we're going to be looking for in lawyers in the next couple of years going forward, and to tell you about this new, the brave new world of IP protection. Thank you.
So it's basically trade
Like,
secrets. Trade secrets.
Yes, that's what we're doing.
Yeah, Michael Nicolay just said, we're talking about trade secrets. Does anybody else here or online have anything to add to that, or any ideas about how that might be addressed? Donna?
I was just going to say that, one of the difficulties in thinking about how to teach this to students, it's kind of I guess, almost a stereotype that people with engineering degrees go into IP law because they've already got the background in science or technology. But they shouldn't be the only people. And even as we talk about some of the more regulatory aspects of what we've been talking about today, I think there is a challenge in making people comfortable with understanding the science behind it and how to teach that. And so, from the perspective of, say, for example, law students, they come in, they do their usual first year classes, contracts, torts, whatever, good basic skills. But now they're here is 2Ls, and they've got this whole selection of things to pick from. And it's scary to say, oh, I'm going to take a course in biofuels where they're going to expect me to know something about how these things are created, or something about agriculture, or something about, because, as more experienced people, we've had a lot of life experiences to pull into this. We didn't come out of law school, those were the lawyers, didn't come out of law school full blown with all the knowledge in our area. So I think part of the challenge is, how do we break this down for people who are entering the field, to take away that sort of scare factor of you've got to be a scientist to be able to do this? Sean?
So coming from a former GW law student, I'm more than happy to tell you. But I am curious because some of these issues do seem, so I'm recently joined ITIF, and I'm learning, and for ITIF is Information Technology Innovation Foundation. It's a nonpartisan think tank that focuses on everything from AI, quantum computing, to clean energy, and bridging the digital divide. So these are all issues that I was not thinking about as a 1L. I wasn't thinking about as a 2L, nor was I thinking about as a 3L. I didn't think about it my first year after law school. So I think just exposure, understanding that these concepts and these issues do intersect in their other areas. One of the reasons that I got into privacy and internet and tech law was because I began to see how it was pervading every other area, every other market, every other sector. And if there's nothing else that impacts everyone, everywhere, no matter what you're doing, no matter what type of law you go into, it's focusing on climate change, focusing on sustainability. And one of the things that I have been looking into is looking at how tech can impact that. So the use of AI, the use of blockchain to help improve the electrical grid, or bidirectional charging, vehicle to grid charging. And so I'm curious, does it seem as though some of these biofuels, there's a quicker pathway to utilizing them to lower carbon emissions, or do you think that maybe something like AI or like some of the tech, is tech too complicated and maybe adding to carbon emissions before it gets to a sweet spot to where it starts lowering carbon emissions, or are sustainable fuels, kind of neck and neck with AI?
Wow. I'm not sure I can answer the AI question, but what I would say is, elements of advanced technology are critical right now to the biofuels industry. One little example, you mentioned blockchain. Increasingly, whether you're a renewable diesel company, whether you're a sustainable aviation fuel, biocrude, ethanol producer, increasingly to demonstrate in a reliable way the life cycle greenhouse gas emissions benefits and other sustainability criteria, and to monetize that in a reliable way. It has always been sort of done on paper in a way, or in simple computer programs. Now blockchain is viewed as a very promising way to do secure transactions, and then to make, even if you don't do physical sale of the fuel, to be able to physically or not physically, virtually sell the environmental benefits and monetize those. So and I think, there are real applications that way. I think the focus on intellectual property and other things is very critical, because all of these fuels, like even if you have 2 companies producing sustainable aviation fuel or 5 companies producing renewable diesel, they have a secret sauce aspect of it, and they want to protect that. But thinking more broadly for law students, if you have an interest in renewable fuels, sustainable fuels, you can take that in so many directions. For me, I'm an environment and sustainability attorney. And to Donna's question, I was a sociology and Spanish major growing up before that. So I didn't do science, but you have to learn conversational science. And you as a lawyer, hopefully, are smart enough to ask the right questions and know how to do that. So I would say a lot of what's going on in biofuels is also policy, and how do you create the structures around being able to have this new market. So for me, environmental law, administrative law, energy law, environmental law, contracts. So even if you're not going to be the IP person, contracts, corporate law things, so that you know who to call or who you're going to bring in for that, or who you're going to work with. And also the point has been made. She had to go to a class, but
Yes.
One of our law students here said that she's doing international stuff. As Bob said, this fuel is, if we're talking a liquid fuel, certainly it's a commodity, and it is, you want to be able to move that around, and you actually really want to have an international market for most of it. And certainly going back to the maritime industry or the aviation industry, those fuels really do move from one place to another. But if you're really good at what you do, you might want to sell your US made renewable diesel somewhere else, or vice versa. So there's so many ways that your energy law students and others can express this if they have an interest.
It's interesting you bring up AI and complex thought processes for doing things. And I know that every few years they tell us in biology that programming is going to save our job. It's good to do it differently. What we found, and I guess 2 points I'd like to make, is that one, if you're dealing with biomass and if you're dealing with enzyme or chemical conversions, AI isn't going to help. What we discover time after time when we're designing enzymes, and sometimes do this sort of as an experiment, you have these AI programs come in and you say, show us what the ideal structure should be. And then we go out and we do some clever genetic work, and it doesn't look like what AI said. so I think, and it sort of leads to my second point is that don't get hung up in complexity. The simple solutions, usually work better. So, when you're trying to apply some of these technologies, it just seems like let's make it more complex because complexity is the solution. Where I think most biologists would argue that, let's try to keep it simple.
There we go. Also to Donna's point also about the how to teach this, how to make this more part of the law school experience. I went through all of GW's course offerings, and I wrote down some notes about how in each of those courses there might be some topic related to renewable fuels that you can include in it. One, in a way that we talked about it when you're talking environmental law. When you talk about the Clean Air Act, talk about how the biofuels implications on the Clean Air Act. When you talk about water pollution, talk about how hydrogen is made with electrolysis, and are there any water pollution issues that might come out of that? We talk about waste management, and part of waste management being reusing that waste and fuels being part of the way to do that. So I went through this, and there was almost every course I could find some connection, some topic that could be rolled into that, just even mentioned on 15 minutes on one day, that will help students understand that when you're going out into the real world of being a lawyer, if you get if you have clients that are doing renewable fuels, that you've heard about it already, that you have some idea how these all these pieces all work together, and how this is not, it's not in a silo, which is something that we've talked about before. You need chemists, you need biologists, you need engineers, you need people to do communications. You need all of these people to make this successful. So I think that would be another piece of your putting the biofuels course together puzzle, is if other faculty also incorporated it, then they would have an idea of what a biofuels course might offer to them, how they could take that to a more detailed step.
But that exactly, I think, goes to why we need to have this conversation today, which is that in order to bring it into all those courses, those faculty people, all of whom have their own expertise and their own 40 years of experience doing whatever, need to have also already known something about this or to see that connection. And while you can see it, how do we make it there, so that others can? Or going to the point about the students. I mean, I'd love to have all of our 1Ls understand how important sustainability is to everything else they're going to do. As it is, I have students that walk into my office and say, oh, I'm really interested in environmental law and energy law, and I don't want to take corporations. I was like, of course you're going to take corporations. I don't care what you want to do. I don't care if you want to, work with it, represent a company or sue a company. You got to know what a company is versus a partnership. Take corporations. So, there's really fundamental understandings of how all these little pieces of law, it's so complex. And that's why I think elevating the public conversation to now I'm getting more and more students who do walk into my office. They say, I've heard about energy, environmental. I know it's important. I don't know if it's right for me, but I want to learn something about it. Yeah. And I think that's a really big bridge right there. But now to get them to that next step of not just that I want to know something about this area, but I want to know about biofuels. I want to know about electrification. I want to know about advanced nuclear. I want to know about environmental justice, and all those little nuanced pieces is the next step that I think is even harder.
I think for myself, I didn't get interested in tech policy, internet law until my last year. I took information privacy, and I also took a policy seminar class. And it was those two classes that really helped me to shape stuff I was hearing about in the news. So I graduated from GW Law in 2017. My last year is when the big fight around net neutrality was happening. And there was a lot going on. And I think that having someone, I had an adjunct professor who his name was David Goodfriend, who was kind of very much so in the space. And I think having someone who is a practitioner, but also helping to connect the dots as to how this issue implicates my life today and how it'll implicate my life tomorrow. One thing I knew, although I knew I didn't know much about tech, I knew I didn't know much about bridging the digital divide or net neutrality. I did know that technology is not going anywhere. I knew that it was only going to advance even further. And so I also knew that as it was continuing to advance, folks were having a harder time understanding it. And I figured, well, why don't I try to be one of those people to help explain it? And so I think that with issues of sustainability, it's helpful to make an impact here, right? And kind of seeing those nuances. I mean, now I can promise you, I did not see myself working in the space that I'm working in now when I was in law school. And so I think that having some exposure to how these issues impact us today, how they impact the Washington metropolitan area or just the United States is really helpful. So I think that may be one way, just my opinion.
Thank you. I'm so glad you came and give us the really recent philosophy perspective. But we've got a new person on the other side of you. Could you introduce yourself, please? You can put the microphone
I don't know how this thing works.
in.
Name is Dave Onswick, retired civil engineer. I found about this event on Eventbrite and signed it up just because I thought it was interesting. I would like to start going to another session at the National Academy of Science. But I'm just interested in the topics it was about, nothing more. Thanks.
Okay, thank you. Nancy, I wanted to ask you to follow up a little bit as we were talking about regulatory issues. Could you talk about skills and knowledge that are important to be taught or learned in educational system, not just law school, that relate to regulatory issues and maybe how that might flow into the ESG, environmental, social, governance concerns that just about every corporation is having these days.
Yeah, I'm sure. And, I'm a huge advocate for a law degree, so because I think you can do just about anything with it. So a lot of what's going on in this space does really involve an understanding of government. A lot of it involves an understanding of the way the regulatory schemes work, and that can be certainly at the federal level and the state level. Somebody mentioned earlier, I think it was you, Joanne, California has a low carbon fuel standard. At the federal level in the United States, we have a renewable fuel standard. Oregon and Washington State now have their own clean fuel standards. It helps, from an educational perspective and an engagement perspective to understand the way that law and regulation works together. And when you're thinking about the biofuel, renewable fuel space, do those things work together or not? Do they conflict? You can have different rules under each one. The same fuel, Bob's fuel, could score differently under the federal program than it does under the California program. So understanding how to work with those types of schemes, I think, is important, and having a lexicon to Donna's point, your point. So environmental, social, and governance has become an expression of outward metric for how we sort of value what we're doing in terms of environmental compliance and advancing it. So environment, social, what are you doing in terms of your own people in your own organization, and what are you doing in giving to the community? And governance, What is your structure to make sure you're doing it right and well? Increasingly, those issues are part of the value of a biofuel. It is how can you demonstrate that you're doing those things right, and how can you then have the metrics to demonstrate that you're doing it right. So when you talk about the skills, part of it is perhaps people like me that understand and have spent some time or will spend some time in the environmental space. Socioeconomic value becomes really important. Governance, back to Donna's point. Sorry, you can't skip contracts. You can't skip local government law. You can't. You need all of that stuff. But in the sustainable aviation fuel area, we have definitely found that you have to work kind of with all of those, and you're not just let's take, I don't know if they're still on the phone, but Delta Airlines, they are buying sustainable aviation fuel. They need to have done that contract right. They need to know what they have. They want to monetize that well. They're paying for the fuel, but increasingly their customers, their corporate customers, say, we care about when we fly our people. You said this earlier, Donna, or Jenna said it earlier, which is, if you've got people in your corporation or your organization flying and you want to have a footprint that you can be proud of, you may want to contribute to buying sustainable aviation fuel on those flights. Increasingly, the corporations are making that kind of partnership happen. So I don't know if that gets to your question. It's a little bit broad, but we have seen increasing engagement by American Express, Microsoft, the JP Morgan and others who fly a lot of people around for their businesses, working with the airlines and working with the fuel providers to help pay for that fuel as part of their contribution.
To add to that, when you mentioned Amazon, they are now in Europe fueling their backup generators with renewable diesel. We have another new person. Can you introduce yourself down at the other end, please? Thank you.
You're on.
Okay. All right, good afternoon. Sorry for delay. We had an executive meeting. I couldn't escape, so I came here as fast as I could. I'll let Donna know. Malik Angalakodati, Senior Vice President, Strategy and Innovation and Business Development, Washington, U.S.
Thank you.
Can I just comment? The people on the phone have been very quiet. We'd love to have you be part of this conversation. Just raise your hand or throw something in the chat if you would like to contribute.
Joe, can you?
Yes, she's
I was not going to let you go. I wanted to know if you could talk about the agriculture. We talked a little bit about needing to know about agriculture and fuel distribution pieces, opportunities that come with this territory.
Well, obviously for many sustainable fuels, particularly biofuels, agricultural is a key component as a feedstock for the fuel. And, we are in a climate era now where questions about the carbon impacts of feedstock production are sort of inescapable. So a lot of what we try to focus on is partnerships with our agricultural community for ways that they can highlight the benefits that they already bring with respect to climate mitigation and the further technologies and innovations that they are currently developing. I think I might have mentioned this earlier. How you model impacts of agricultural feedstock inputs matters a lot. And if those models are inaccurate and they don't capture the full range of the carbon life cycle, then they're not going to get the credit that they deserve in the agricultural community, and that will potentially de-incentivize further innovation as well. Because if you have a lot of investment in innovations that are supposed to reduce carbon emissions, and those are never recognized in a regulatory scheme or in the science that's used to support certain different regulations, you're not going to have folks engaging in that type of work.
Could you, I don't know if these are your members or not, but can you talk a little bit about what GEVO and Amyris are doing?
I can't speak to what they're doing. So GIVO is in partnership with one of our members to develop some sustainable aviation fuels at with our ethanol producing facility. So the technology there being developed is eventually sort of standalone SAF facilities for alcohol to jet. Because there are, again, different feedstocks that can be used in sustainable aviation fuel. Some are lipid-based, some are alcohol-based. And again, there's different incentives in place for getting those technologies developed. So that's a new area. Our industry is expanding beyond the light-duty vehicle market, which has been the primary basis of consumption of ethanol, denatured ethanol in the United States. So that's on the ag side. You mentioned fuel distribution. I think Bob mentioned that most of the transportation of ethanol is through rail or barge or trucking. But with respect to the climate impacts of the industry, there's a lot of discussion and a lot of development about carbon capture and sequestration and carbon pipelines. And that relates really to the geologic sort of situation in the United States. Some places are better set up for sequestration than others. So it becomes a transportation issue. How do you ensure that you get the benefits and get the credit for carbon sequestration? If you live in an area, if your facility or your agriculture is in an area where you can't just inject it into the ground where you are. So that is being developed across the Midwest. You have a number of companies who are trying to work on carbon pipelines, which raise their own environmental sort of concerns, just like oil pipelines do. But I think thinking holistically about the impact of those sequestration efforts is sort of the best way to assess their environmental value overall. I don't know if that answers what you're getting at.
Yeah, and I think the other thing that I was thinking of was how GIVO and Amyris are incorporating renewable natural gas and really working contracts, agreements, partnerships with people along the in a sort of from the feedstock providers and their electricity, their power providers, to make everybody that's going to do business with them have to meet sustainability criteria, or that they work with them to develop partnerships and projects that are specifically geared to reducing the carbon footprint of what's coming out as their product.
I couldn't speak specifically to what GIVO is doing, but I think on your broader point about sort of contractual relationships as a means to ensure that the benefits are being realized throughout the entire supply chain, that's certainly a strategy that people should engage, involve. But I don't really have a lot of insight into their particular relationships.
Thanks, yeah, Nancy.
I can speak a little bit to GIVO just very quickly. I mean, 4 of the Airlines for America members have offtake agreements with GIVO, so I have paid some attention to them. I think, they are already producing ethanol and they can do ethanol to jet, alcohol to jet. But I think where they're making a lot of, where they're getting a lot of attention now is they're developing what they call their net 0 facility. And that's where a lot of the airlines are particularly focused on getting offtake. And what I think is basically, as Joe was saying, part of what's innovative about it is they're looking to combine the climate smart agricultural processes that can produce corn and agricultural residues. So really have a lot of good soil carbon sequestration and farming practices. They're looking to separate some of the energy value then of that corn and still preserve the protein value as well. And the technology now is allowing them to do that. But I think also significantly, they're looking to have wind power so that they reduce their own carbon footprint and they're able to power their operations in a renewable way. And the point there being, you want to have a biofuel, and hopefully they will be successful at that. They broke ground this fall. So, but this is a good sort of reasoned plan for getting your carbon footprint very low and being able to meet those sustainability values across the board, that you're preserving the soil, you are contributing with the different products, not just the fuel product that you have. And you're basically becoming self-sufficient in terms of your own power. So I think, you know, I wish them luck, and I wish my former airline members a lot of luck in what they're trying to do there.
Thank you. Yeah, Michael.
Anybody here familiar with the seawater to fuel project at Naval Research Laboratory? There's I think she has a physical chemistry degree, if I'm not mistaken, but she's a researcher. I met her a few years back. Basically, she developed a technique for extracting carbon dioxide out of seawater, and then developed the chemical process. I don't remember exactly how it worked, but uplinking that to become a synthetic replacement for jet fuel. And, you know, the whole process is there. It's just add energy. So you have to have some sort of an energy source that will cause that to happen. And what would be a good energy source for doing that? And by doing that, you completely sidestep the need to touch the land in order to get your replacement for petroleum. Just be done by a chemical process.
Yeah, I think that I think there's something on our website about that. So probably could look it up by a word search, but that does sound familiar to me. I think that we have put something in about that.
They did their experiments on extracting carbon dioxide at Key West. They have a naval facility down there, and they did that for a number of years. Anyway, the other thing I'd like to bring up is that David McKay, it's a physicist in Europe. Well, he's passed away. He's a physicist who wrote a book called Sustainable Energy Without All the Hot Air. Anybody read that? Because actually, if you want to give your law students something to read, get a better understanding of it, this guy debunks a whole bunch of stuff very well, and towards he's a very good communicator, did a great job. And he had a TED Talk called A Reality Check on Renewables. And he basically said, okay, we're going to take a scenario just to see how dense are these renewable energies. And so he said, you take 60 miles per hour cars that get 30 miles per gallon, 1,200 liters of biofuel per hectare per year of land, and 80 meters between each car. So he's basically turning it a 1D problem that's easy to solve with, you just do the back of the envelope calculation. So how wide do you think plantation along the side of that road would have to be in order to fuel all of those cars? Any guess?
I don't think I agree with the premise.
Yeah,
but
I think that's kind of a stupid thought.
In what way?
Thought experiment.
No,
because that's not how you grow. That's not how you grow things.
No, I'm not saying it would be there. It's just that how much land would you have to have devoted to
that? I don't
You
think
don't
that's
have your microphone.
That's okay.
It's not. This is actually a good way of looking at it, and saying how much land is required to do it. And it's all about energy density. It turns out to be 8 kilometers wide in order to support that one row of traffic.
I think the assumption that probably we're arguing about is how much fuel can you get out of that amount of land. And I think that when we're talking agricultural residues and things like that, that number fluctuates when we're talking in any conference you go to about how much what's the energy or fuel yield. So
even if you cut that in half or a fourth, they're still talking about a kilometer wide path associated with that particular road and all the roads. So it is a way of giving you a scale that this is not an insignificant amount of land that you have to have available. And that's kind of my point that I wanted to make. We currently use 3 cubic miles of oil equivalent from natural gas, coal, and petroleum every year. And that's a big piece of space that is a liquid fuel. And one of the problems that we have is that these fuels are very low energy density compared to nuclear power. In nuclear power, you have 1 million times the density of the equivalent of fossil fuel, because physics, fission splitting is very different than chemical splitting. When you break a hydrocarbon bond, you basically are getting a very small amount of energy out of it. But when you fission a piece of thorium or an atom of thorium, you get a whole bunch of energy out of it.
Okay, Nancy wanted to respond?
Could we get back to one of your original questions?
Nancy.
If you want to respond to that, because I don't.
Yeah, I was just going to say, I don't think anybody would disagree that nuclear is a lot more powerful, but you're not going to power an aircraft anytime soon. Passengers are going to be on with that. I mean, I think part of the point is to really the premise that Joanne and Donna gave us at the beginning. It's sort of an all of the above strategy, and you're going to use different strategies, different feedstocks and technologies for different purposes. So I think that's why I don't want to speak for Bob, but I think we were thinking your example was reductive because it was it's sort of forced into a premise that isn't necessarily an acceptable premise. Yes, you could say if we're only going to do something with X crop or Y crop, how much energy density can we get per acre? But that's sort of a false question. It's a singular question for a certain thing, and I think that that's my point. Also, most of the renewable fuels are now driving towards the standard of an energy density. They have to be comparable, again, in the replacement scenario for petroleum. And so the energy density is increasing and increasing with the technology approaches.
Thank you, Bob.
You were back talking a while back about regulations and regulatory experience and what have you. Something that I think was important when I worked with council governments and DC government and other places was I actually got to write regulations, and it's fun after a while, and well, in a way, it's fun if you. But the point was, I think it's fun. But anyways, I think one thing in law school and GW has so many clinics and all sorts of these outreach things that I think getting the opportunity to write regulations, be it at a municipal or state level, will really teach you a lot about regulations. And I think it's something to really be pushed, in the clinics around here. Because I mean, the state of Maryland's always writing regs on everything in the whole world. They're always looking for people to help them. And so, it's something that, I think, learning how to write regs is an important thing. And something else that, when you're talking about corporate law, nobody in this part of the East Coast teaches about co-ops. If you want to learn about co-ops, you have to go to University of Wisconsin-Madison at their co-op center. But so much of agriculture and so much of biofuels are co-ops. So if you really want to be able to, have a future in working with biofuels and agriculture, you really need a background in co-ops.
I'll continue on that education issue. I was wondering if Jenna Bluxham is still there. Could you talk? You were talking about your multidisciplinary educational program, can you talk a little bit more about how that worked and how that might be a way to address some of these issues that have been raised here about how multidisciplinary this kind of work can be, and how that system that you were part of might be a model for addressing some of these questions?
Sure, absolutely. So yeah, I was part of the National Science Foundation's Agri program, which was very much geared to be a multidisciplinary program to bring together people from different disciplines and really kind of let them hash it out together. And I was the second cohort. I think CSU had this grant for about 6 years, and I was the second cohort, and I was the first political scientist of the group. And so our cohort was 6 people, 2 chemical engineers, a mechanical engineer, soil scientist, and a biological engineer. And so we all worked together taking not only classes in different fields kind of separately. We got to kind of choose what classes we wanted to take within our own kind of research interests. But then we also took 2 classes together, just our group, and we did group projects together. We went to Washington, D.C. together to speak to lawmakers. And, it was a very interesting time because we all knew a lot about biofuels, but we didn't know a lot about what the other people knew about biofuels, I suppose would be a kind of simplistic way to put it. Some of these people were very brilliant, but they honestly hadn't talked about how the government worked or the 3 branches of government since they were in elementary school. And as the political scientist, that was rather interesting. We also did lab rotations. So that was interesting for me as a social scientist to go into the lab and see how that worked. And I think we all walked away with a profound respect for kind of the other disciplines and saw the kind of differences between them. But it really made an impact on not only the way that I did my research, but I think other people as well. I used to always tell the engineers, you can make the most efficient technology out there, but if it's not going to be politically popular, it's not going to be adopted, it's not going to be something that's going to be used. And I think that was a real blow, because if you just focus on efficiency or you just focus on, regulatory possibility, I think there's a lot of lost in translation issues that occur from both of those. So I definitely would recommend a multidisciplinary program, and I try to incorporate that when I talk to students now, encouraging them that there's not one perspective that's correct. You just really have to see it from everyone's ideas. And I see that also in publications in political science for policymakers, is that we do analysis of technologies, but they don't really understand the technologies. And that becomes very problematic as well.
Thank you. On that, I'd like to ask Bob Kozak to continue on an idea that he's had regarding training on another group. He's suggested mechanics training to retrofit old cars to use E85 as a way where we were talking about how can we most quickly replace our use of petroleum fuels, and E85 is certainly one way to do that. And my old Focus 2002 Focus, we did a retrofit on it, and before it really completely died at the age of about 20, we had like 60,000 miles as an E85 car, and it was great. It increased its performance, and it liked going over the mountains around here. But so he had an idea about a way to do that.
Which one was this?
The mechanics training.
Oh. Actually, if you're talking about mechanics training, you remember Professor Wrightsey?
Well, he left before I came, but he is legendary around here.
Yes. He was in I first met him when I was running the emission testing program for the District of Columbia. And this guy was legendary. And, this guy's going, I'm this law professor, like talking about your program. And I was going, oh, geez, another law professor. So I started asking some people, Wrightsey? They go, yeah, he is certified in every ASE mechanic thing you can get. He was certified in air conditioning, transmission, emissions. One guy who was the dean of Northern Virginia Community College, he goes, yeah, that guy's one of the best mechanics around. So, I immediately called him, and, he was like involved with, I said, so I'd like you to work on the regs. He goes, no, I want to develop a mechanic training program for you. So, we had him on the mechanic training program. So I tell you, there's this thing about it. But what was interesting when we implemented the emission testing programs nationwide, if you all know that tailpipe where it's stuck up, the probe stuck up your tailpipe, and it sounds really awful, and it isn't really. But that program, we were very concerned on a national level of acceptance of the program, and it was some really brilliant people, including Michael Walsh and people, Gemma out at Colorado State University, who said, like, look, we're going to have to upgrade the mechanic training force in the nation. And if we upgrade the mechanic training force, they can teach the consumers about what is good about reducing emissions. So we, in all of our individual states, we set up mechanic training programs, and we went through all this. We got ASE to create a new category for emission testing. And what happened was, we thought these programs were not going to be accepted. We, were told that everybody's going to hate it. The hot rodders are going to hate it. The lefties are going to hate it. But everybody said, no, what we liked about it was you upgraded the mechanic force so much that, and this is kind of interesting, if you look at, when how you rank industries, how are people into that? If you go back to like 1975 to 1980, mechanics were always at the bottom. And if you look at surveys now, mechanics are at the top. And the reason that happened was that they became well trained in this, and therefore they could communicate information to consumers about, clean emissions or good emissions. And I was thinking about this, that, there's a large proportion of the vehicle fleet now. It's at the oldest it's ever been. The average age of the vehicle fleet in America is somewhere around 14, 15 years old. And that's basically because, one, cars last well now due to clean air regulations and warranty requirements in the Clean Air Act. And two, cars have just gotten too expensive, so people keep them for long periods of time. So this gets back into well, what can we do to reduce CO2 right now? Well, why don't we change the fuels? Because these people are not going to be able to buy electric cars probably in their lifetimes. So why don't we do something like this? So when we're saying mechanic training, why don't we duplicate what was done in the inspection maintenance programs to start offering training to mechanics at the community colleges of how to retrofit a car. And the parts and the equipment are there, and they're certified by EPA and by California Bureau of Automotive Repair. So there are things you can do legally. And if we could get mechanics certified in this, that when people with older vehicles are going to start asking, well, is there anything I can do? And they'll have a mechanic there or a service writer at a dealership and go, well, yeah, you actually can do this. We're certified to do it. There's certified ways, there's certified ways to do this. And, if you really want to talk, for a big bang for your buck, the parts to retrofit a car to E85 are about $400 to $600, depending upon what's already on that car. So it's not all that expensive. And, you could set up, the way I'm looking at it is the community colleges could set up, low-cost clinics. If you're looking at environmental justice, you have a 10-year-old Focus that could be converted to a clean fuel. It would be a real quick way. You could suddenly go, wow, we have replaced more fuel. So it seems like and if you want to see how to do it, look at the CSU program, or you could go to Northern Virginia Community College or any other community college probably in the country that has a mechanic training program. They'll tell you how to do it. And they said, yeah, we would love to do this. Let's get an ASC certification for it. And, let's do it the right way.
And so you need to know right seat.
Yeah, I've never heard that before about Arnold Wrightsey, but it only adds to the legend. We are still in contact with him. Next time I'll have to mention that he's known for that still. That's great. Although I don't think, despite that, we're going to set up a training program right here. But I think the environmental justice aspect is actually a really interesting piece to that too. I have a question though. So if you're retrofitting cars to E85, are there different standards? Okay, we have the 10% blend. I've seen the E85 mostly in Iowa. Are there other standards, and does that create if we start retrofitting cars, are there different, is there a 100% standard? Is it different how you would, does it matter?
And Joe can probably do a little more detail on this. E85 is one of these things that kind of happened by accident. I mean, almost everything with ethanol fuel happened by accident. That it was like, well, what's the maximum number we could go with? Because you need lubricating properties in your fuel, and ethanol has lots of good things, but doesn't lubricate very well. So somebody at EPA came up, so let's say E85 is the maximum. So it then became E85. Now the reality is that when you're buying E85, it often isn't up to E85.
Okay.
It can be E65, E70, depending upon time of year, all sorts of other things that get involved. And so we just use that term of art of E85 is, yes, it's an EPA certified fuel. Yeah, it's there.
What about the E60?
Yeah, I mean, so when we say E85, it's up to E85. Most of these retrofits have octane and ethanol detectors in there where they can pretty much tell what's in there, and they send a message to your computer to operate that way. And this whole thing, we've E15. Well, every car sold in the United States since 2002 can run E15. When you get up above that, you really do need to change things, but that's just sort of like E85. You go in a gas station, there's an E85 pump, and that's it's something above 25 and less than E85.
That's helpful. Thank you.
I think it's actually 51%, 51 to 85. Joe, do you want to have?
No, I was just going to say, respect to other higher fuel blends, E15 is the highest legally approved gasoline fuel at this point. And I think once you get into higher fuel blends as well, you might run into some infrastructure certification challenges. So for example, the E100 is not currently, there's no current infrastructure that's certified from, tank to pump to dispenser that will allow for E100 to be at a retail gas station. And with respect to the retrofit, I like the idea. I think automakers have largely given up on creating flex fuel vehicles, but even marketing them, because a lot of vehicles on the road in the past few years are actually flex fuel vehicles, but they're just not sold as such. So a lot of consumers, my brother, for example, has a truck that's a flex fuel vehicle. He had no idea that he had a flex fuel truck. Still not putting E85 in it, but I think it's a real challenge because the automakers have, in many ways, kind of moved on to electric as the next frontier. And flex fuel had this window of opportunity maybe 10, 12 years ago, still pretty strong in California. I think it actually has the highest volume of E85 fuel sales in the United States. And it's unfortunate that fuel category has been kind of leapfrogged over because it really would give pretty significant benefits without sacrificing a large amount of energy density when you compare it to its cost savings. I think that's the other pieces. People often think of biofuels as being more expensive, and it depends on the biofuel, right? Part of the education is to also talk about cost savings on the consumer side. Ethanol, for example, E10 fuel is cheaper per gallon than gasoline in almost every scenario. And in particular, last year when the gas prices spiked because of the Ukraine invasion, that margin got even larger. So one of the pieces of education is we assume that quote unquote new technologies are always going to be more expensive, and often they are in the initial development period. But highlighting consumer savings as part of the overall sort of package in selling, for lack of a better word, the biofuels message is an important piece of this, the economic arguments.
And on the E85, on E100, but in Brazil, they have E100, it's hydrous ethanol, but the cars down there can go on that hydrous E100. And in France, when the prices of regular gasoline spiked, there are many people who have retrofitted to E85, and Total Energies has like something like 800 of their fuel stations now sell E85 because it brings in customers to go to their C stores.
Yeah, and I was actually in France last summer, and I took a picture of a Total sign where they were showing the prices for E85 versus regular gasoline. It was this enormous increment, like 20% savings, $1.20 a gallon difference this past summer. So definite benefits in France.
Which then brings us back around to the environmental justice issue. This is for people who are not going to be able to afford a electric vehicle for maybe generations. And for people who have cars that want to keep them for that, and it's cleaner burning. There's the Urban Air Institute, that is their main focus, is trying to explain that using ethanol takes out benzene and a lot of other toxic chemicals that you need if you're going to have gasoline, and if you have the higher blends of ethanol, that is an environmentally smart thing to do. So I think that also when you're talking about renewable diesels, also there's less soot, less particulates, and these other benefits that are relevant to an environmental justice discussion. So I think that was one of the other topics that we wanted to talk about today, and I think that's a couple of ways that this is relevant to that. And anybody think of any other ones? Nancy?
Yeah, I think the environmental justice issue is pretty important, and it kind of reaches into a lot of different areas. So the examples that you all have given, started by Bob's discussion, I was on the state of New York's climate advisory board for a couple of years when they were formulating their current plan. So 2021. And I was interested and surprised that the advocates for environmental justice were very concerned about EV, electric vehicles, for the very reasons that you're talking about, affordability, but also access to charging. And they were keenly focused on the biofuel alternatives, knowing that we needed to do a transition, knowing and eventually wanting EV, but how is that equitably distributed? But then when I worked for a biocrude and sustainable aviation fuel company, I was also fascinated by how important the environmental justice issues were when we were talking about where we were doing our first facilities. And it was, we're going into a community, you are going to use feedstocks in that community. For us, it was going to be agricultural waste and other waste things. So you think that's a good thing. You think you're going to cite and bring jobs, but you also have to think about what is your environmental impact? And what kind of jobs are you bringing? Are the jobs that people there are trained for? How do you train them? How do you deal with the workforce issues in an area where you're excited that you have agricultural residue or you have this or that, but you might not have the workforce that you need for advanced biofuel production or whatever. So it is an exciting area. I know that we don't have all the answers. For those of the folks listening that are interested in environmental law, it's a very developing area. And some of the new tools, like the Environmental Protection Agency has a tool called EJ Screen that allows you to look in areas and see what the impacts are. But it doesn't exactly tell you how to judge the outcome of that, what you do about that as a practitioner. It gives you metrics. And so I think it's a really exciting area for lawyers to think about, policymakers to think about, not trying to overdo it, but understand it and work it.
Thank you. Anybody we're getting close to the end here. Anybody else want to make any summaries, any concluding remarks, anything that we've missed that we really should have been talking about? I don't see any Okay,
So,
Yes.
sorry, I missed most of it, but are you defining sustainable fuels narrowly on liquid biofuels, or is it a broader discussion around renewable electricity or clean hydrogen? How are we, I mean, how is it framed? Because I missed the first part.
I will tell you how I personally do it as the executive director of Advanced Biofuels USA and the one that puts together the website and keeps up the library. I talk about it very broadly. So when I'm talking sustainable fuels, I will include hydrogen, and partly because hydrogen it can also be a co-product of making some of these other fuels. So if you're making renewable natural gas, that system, you've got biomethane, you might be also have the opportunity to make hydrogen. Or if you have your CO2 fermentation co-product, then where you're going to mix it with hydrogen, and then you've got an e-fuel. So I treat it very broadly. There is other philosophies that would have a much narrower. When we talk sustainable aviation fuel, does that include hydrogen or does it not? If you just take the word sustainable aviation fuel and it's green hydrogen making your e-fuel, to me, that's a sustainable aviation fuel. Some of the SAF people say, no, it isn't. Nancy.
Right. I can clarify that. I mean, I think anybody in the aviation space wants all of the above. And the pure distinction between something, basically sustainable aviation fuels right now are largely defined in the aviation sector as liquid biofuels or liquid renewable fuels that can include hydrogen, but fully changing the aircraft to a true hydrogen powered aircraft that is not a liquid fuel, but using pure hydrogen. That is not typically in that category, completely for regulatory arbitrary purposes. It is because there are systems being developed for certain kinds of research and development, certain kind of fuels. And so, like originally, actually, sustainable aviation fuel, we all called it alternative jet fuel. We wanted to keep calling it alternative jet fuel. And that would have probably distinguished it from like new types of energy, new types of engines and aircraft and others powered in a different propulsion system. But I'll tell you, the International Civil Aviation Organization, the UN body that establishes standards for international aviation, decided on the sustainable aviation fuel tag rather than alternative jet fuel, and it stuck. So I missed the time where we talked about it as ATJ or alternative jet fuel.
I'll just add to that. I think the definition should be as technology neutral as possible, but by reference to metrics, sustainability metrics, like the Inflation Reduction Act, for example, qualify for a credit as sustainable aviation fuel. You have to have a certain percentage of greenhouse gas emissions reductions. There could be some non-climate based environmental metrics that you also apply to as well. But that's kind of how I think about sustainable fuel, is more like what makes it sustainable as opposed to what kind of fuel.
I'm glad to hear it, because I come from electric and gas utility world, and that's where we are ending up. For electrons and gaseous molecules used through utility value chain, has all options should be on table. People have different perspectives, but I don't see how you can decarbonize electrics sector just by narrowly focused on renewable energy like solar and wind without hydrogen or renewable natural gas. So glad to hear that aviation fuels are being looked at through a broader lens. More pragmatically, I mean, we just wrapping up our regional hydrogen hub application as part of Mid-Atlantic hydrogen. That's one of the reasons why I'm pretty busy these days. It actually includes aviation. Can't disclose there are some startups involved, but hydrogen fuel cell based aircrafts are in the proposal. So, which is an interesting development.
Well, we're talking about words. My preferred word is defossilize. Because we're talking hydrocarbons.
Right.
A lot of hydrocarbons. When we talk about just hydrogen, yeah, we're not talking about hydrocarbons, but hydrogen can be included in that defossilization. But that's really the main objective of all of this.
Let me ask you this, from that lens, what would you think of blue hydrogen, which would be stripping carbon atom out of methane? It's not sustainable for sure because it originates in fossil value chain. But could it help balance energy system? Perhaps.
And just to bring it back to your question, I mean, I started this whole series because but well, we're not teaching a course on alternative fuels of any sort. Where do you approach this? And I thought that there were like categories, but it really is sort of more of a continuum.
Right.
As we think about the inputs and the processes and the uses, there's so much room to move between these. So we did have the one program on hydrogen, and we had a program on sustainable aviation fuels. And so this one, I think, focused a little bit more on liquid biofuels, but only as a matter of convenience and how to talk about them because there's so much depth in each of those areas.
Right.
And again, they're all kind of blended. It is really a continuum.
It is a blend.
And I think that is part of the problem in talking about this area with whether it's students or investors or just the general public. You know, we started with what are the misconceptions? And part of it's just, what is it? What are we talking about? And Joanne gave us a great introduction, but I think the challenge I still see is how do we make this bigger? How do I have students walk into my office and say, I'm really interested in, and, you know, bring this into the conversation. You know, it's getting to the point where they kind of like, okay, they know about EVs. They have, you know, sustainability generally, environmental justice. I do get questions about those things. I don't have anybody walking to my office yet saying, I want to learn more about how we do technology neutral carbon reduction using sustainable biofuels. Nobody's asked me that yet. So that's kind of where we're coming from. And so I think your question is very good, but that's part of why you're hearing a lot about liquid biofuels today.
So I think that might be a great way to wrap this up because this is, we're used to being trailblazers in this biofuels world or sustainable fuels world. Thank you very much for having GW Law host this and help us bring these people together. And we will all, I'm sure, and anybody online too, be willing to, as you develop this course, reach out and we'll put our heads together and do whatever we can, make it happen. Thank you.
Thank you, Joanne, for being a fantastic co-host or host for this. I obviously could not have done actually any of this entire series without your input. And I'm still trying to figure out how exactly we're going to get a course on this into the curriculum or what it's going to cover. But I think I'm getting at least closer. So thank you all for attending today. Both of you, those of you online who've still hung in all the way here to the bitter end, and those of you here in person, and including those who had to leave. So I really welcome your continued contributions. This is our last energy-focused event for this semester. We do have a couple more environmental events next week. You're certainly welcome back. Keep watching our events online, and we'll try to let you know when we have some other more exciting programming coming up. Thank you.